I have lots of ideas. Some of them are bad, some of them are good. So this is going to be a bad idea. I thought that the drop-off from students doing WebAssign might follow the same trend as people not going back to their follow-up visits after surgery. And you're going to find out it's not true. It is not a good assumption. So here is data from, I think I took 3 sections from last year. These are WebAssign numbers. And this right here is the number of students who completed it. So I can go in and look at if they never started it and so forth. There was about 60 some cadets involved. So already we have off the bat 9 people are not doing it. And you see that number bouncing up and down and then towards the end. So this is just data, the raw data. It would just be the similar thing as if I asked Dr. Cottom to give me how many patients came back for a follow-up visit number 1, follow-up visit number 2, and so forth. Over here, what's going to happen is I'm going to copy and paste data. If this is P sub 1, P sub 0 goes here. If this is P sub 2, P sub 1 goes here. So all I did to get this data is I went, copied and pasted everything but the last line, because it's not going to have room, and then put it over here. So I did that. So that's where those numbers came from. So this is P sub n minus 1 as the x, and this is P sub n as the y. And then I plotted them against each other. So I went and just highlighted the 2. I go to Insert, I go to Charts, and I scatter plot them. And if you look at this, it doesn't look like a line here. It's hard to see. So I'm going to change the axes. See, I'm going to format the axes. So the data looks like it's between 40 and 55. So I'm going to put here 40 and 55 so I can see it better. And over here, I'm going to put it between 40 and 55 also so I can see it. And you see it kind of doesn't look linear. It looks like a scatter of stuff. If I want to put the line in there, I can do whatever I want. That's what Colonel Watt said. So I can go here, right-click the data, and go to Add Trend Line. And it'll put a line there. The formula for that line, you just have to click down at the bottom here, Display Equation on Chart. I also automatically display R squared. If that R squared is close to 1, then it's a good fit. And you see that R squared is not close to 1. We're going to learn about R squared a little bit more later. I'm going to make this chart look nice. My idea was a bad idea because the data doesn't look linear. And in fact, it looks like from the drop from previous to next doesn't have a rhyme or reason. It kind of does if you go look at the data a little bit more and think about why. But anyways, here's the A would be 0.1826 and the D would be 41.193. And Colonel Watt said we can do whatever we want. I have a bad model, but let's just do it. My initial condition is P51, and then my A is 0.1826. It's the slope of that line, and the D is 41.193. And so I can put in the recursion like we've done in class, drag it down, and these are the numbers I get. Well, it looks like they're not really matched up well, but I can actually plot one against the other to see how good it does. And again, I have this problem with the axes. So let me make this 40 to 55 so I can see it better. But you can see it doesn't look good. So this is what we call validation. I've got to kind of check how well my model is doing, and it doesn't look that good. So if it was a good model, the model predictions and the actual data would be lined up equally, and it would look like the line y equals x. But it doesn't look like the line y equals x. And so what I should have seen is, let me see if I can find it doesn't matter. I think I can find a picture to show you in class, but it would lie perfectly along the line y equals x, so it doesn't. So I would say, I would classify this as a bad model because it's built on a bad assumption. over here. There's no wrong assumption. I can assume whatever I want. I can do whatever I want as a modeler. It's just not a good assumption. But anyways, for your project, you'll be doing the same. You'll be getting data from homeless veterans in the area and region you choose, and you can do the same thing to estimate the A and the D from the data using the fundamental graph, just like I did here.